Factorial notation plays an important role in the binomial theorem. If n is a natural number, this symbol, read as n factorial or factorial of n, is defined as n times the quantity n minus 1 times n minus 2 times n minus 3 and so on times 3 times 2 times 1. Examples. Evaluate the following. 4 factorial is equal to 4 times 3 times 2 times 1, which is equal to 24. 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5040. 12 factorial is equal to 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and that is equal to 479,001,600. So that is how you evaluate a given factorial. Here are some properties of factorials. Number 1, by definition, 0 factorial is equal to 1. 2, if n is a natural number, n times n minus 1 factorial is equal to n factorial. The pattern in the algebraic expansion of a power of a binomial can be contracted. This contraction is referred to as the binomial theorem. This theorem states that if n is any positive integer, then a plus b raised to n is equal to this expression. A raised to n plus n over 1 factorial times a raised to n minus 1 times b plus n times n minus 1 over 2 factorial times a raised to n minus 2 times b squared plus n times n minus 1 times n minus 2 over 3 factorial times a raised to n minus 3 times b raised to 3 plus and so on plus b raised to n. Example. Expand x plus 2 raised to 5 using the binomial theorem. A is equal to x, b is 2, while n is equal to 5, the exponent. Here, we're gonna stop at 5 factorial in the denominator since the value of n is 5. Then, we're gonna follow the pattern in the numerator until we arrive at 5 factorial in the denominator. So x plus 2 raised to 5 is equal to a raised to n or x raised to 5 plus n, which is 5 over 1 factorial, times a raised to n minus 1 or x raised to 5 minus 1 times b, which is 2, plus n times n minus 1, which is 5 times 5 minus 1 over 2 factorial times a raised to n minus 2 times b raised to 2, which is x raised to 5 minus 2 times 2 raised to 2, plus n times n minus 1 times n minus 2, which is 5 times 5 minus 1 times 5 minus 2, over 3 factorial times a raised to n minus 3 times b raised to 3, or x raised to 5 minus 3 times 2 raised to 3. After this, the next term will be n times n minus 1 times n minus 2 times n minus 3 over 4 factorial times a raised to n minus 4 times b raised to 4, or 5 times 5 minus 1 times 5 minus 2 times 5 minus 3 over 4 factorial times x raised to 5 minus 4 times 2 raised to 4. Remember, since the exponent of the binomial is 5, we're gonna stop at 5 factorial. So the next term after this is n times n minus 1 times n minus 2 times n minus 3 times n minus 4 over 5 factorial times a raised to n minus 5 times b raised to 5, which is equal to 5 times 5 minus 1, 5 minus 2, 5 minus 3, 5 minus 4 over 5 factorial times x raised to 5 minus 5 times 2 raised to 5. Simplify, we copy the first term x raised to 5. 1 factorial is 1, so 5 divided 1 is 5, then x raised to 5 minus 1 is x raised to 4, times 2. 2 factorial is 2. 5 minus 1 is 4, times 5 is 20. So 20 divided 2 is 10. Then, x raised to 5 minus 2 is x raised to 3, times 2 raised to 2, which is 4. 3 factorial is 6. 3 times 2 times 1. 5 minus 1 is 4, and 5 minus 2 is 3. So 5 times 4 times 3 is 60, divided by 6 is 10. Then x raised to 5 minus 3 is x squared, times 2 raised to 3, which is 8. 4 factorial is 24. 4 times 3 times 2 times 1. Recall that 5 times 5 minus 1 times 5 minus 2 is equal to 60. Times 5 minus 3, which is 2, that is equal to 120. And 120 divided by 24 is 5. Times x raised to 5 minus 4, which is x, times 2 raised to 4, which is equal to 16. And finally, 5 factorial is 120. 5 times 4 times 3 times 2 times 1. Remember, 5 times 5 minus 1 times 5 minus 2 times 5 minus 3 is equal to 120, times 5 minus 4, which is 1, that is still equal to 120. 120 times 1 is 120. Divide by 5 factorial, which is 120, that is equal to 1. Times x raised to 5 minus 5, or x raised to 0. 5 minus 5 is 0. And x raised to 0 is also equal to 1. So we just simplify 2 raised to 5, which is equal to 32. Simplify further, we get x raised to 5 plus 10x raised to 4. 5 times 2 is 10, plus 40x raised to 3. 10 times 4 is 40, plus 80x raised to 2. 10 times 8 is 80, plus 80x. 5 times 16 is 80, plus we copy 32. And this is the expansion of x plus 2 raised to 5 using the binomial theorem. If only a particular term in the expansion is desired, the following formula can be used. The rth term of a plus b raised to n is n times n minus 1 times n minus 2 and so on times n minus r plus 2 over r minus 1 factorial times a raised to n minus r plus 1 times b raised to r minus 1. Examples. Number 1, find the 7th term of 2 minus xy raised to 11. Since we're only looking for a particular term, we're gonna use this formula where r is equal to 7, the term that we're looking for, n is 11, the exponent, a is 2, the first term in the binomial, while b is negative xy, the second term in the binomial. But before we substitute these values into the equation, we first need to find the value of n minus r plus 2. So replace n with 11 and r with 2. And simplify. 11 minus 7 is 4, plus 2 is 6. We'll get back to this later. So the 7th term of 2 minus xy raised to 11 is equal to this. We substitute the following variables with its given value. Now in the numerator, we have 11 times 11 minus 1 times 11 minus 2 and so on up to 11 minus 5. Now you might ask, bakit hanggang 11 minus 5? Take note that earlier we solved for n minus r plus 2, which is equal to 6. This means that the last value here in the numerator when simplified should be equal to 6. Sa madaling sabi, hanggang sa anong value natin ima-minus ang n, in this case that is equal to 11, para makuha natin ang 6 na value. And that is up to 11 minus 5 because 11 minus 5 is equal to 6. We're not gonna end at 11 minus 4 because it is 7. And the value of n minus r plus 2 is 6. Nor we end at 11 minus 6 because it is only 5. That is why it is important to first solve the value of n minus r plus 2 before we determine the value of a particular term of a binomial. And so we simplify. This is equal to 11 times 10 times 9 times 8 times 7 times 6 over 6 factorial times 2 raised to 5 times negative xy raised to 6. Copy 11. 11 minus 1 is 10, 11 minus 2 is 9, 11 minus 3 is 8, 11 minus 4 is 7, and 11 minus 5 is 6, over 7 minus 1 factorial, which is equal to 6 factorial, times 2 raised to 11 minus 7 plus 1, which is equal to 5. So we have 2 raised to 5 times negative xy raised to 6. 7 minus 1 is 6. 11 times 10 times 9 times 8 times 7 times 6 is equal to 332,640 divided by 6 factorial, which is equal to 720. So 332,640 divided by 720 is equal to 462 times 2 raised to 5, which is equal to 32, times negative xy raised to 6, which is x raised to 6 times y raised to 6. Multiply the constant terms. 462 times 32 is 14,784, and copy x raised to 6 times y raised to 6. Thus, the seventh term of 2 minus xy raised to 11 is 14,784 times x raised to 6 times y raised to 6. Another example. Find the fourth term of the binomial expansion a plus b raised to 10. Since we're looking for a particular term, we're gonna use this formula where r is equal to 4 and n is equal to 10. Since the variables of the given binomial are already a and b, we no longer need to replace the variables in the formula. But first, find n minus r plus 2. N is 10 while r is 4. Simplify. 10 minus 4 is 6, plus 2 is 8. This means we need to subtract 10 by a number which will yield a result equal to 8. So we replace the variables with its given value and simplify. Take note that in the numerator we end at 10 minus 2, since 10 minus 2 is equal to 8, which is the value of n minus r plus 2. Simplify, we have 10 times 9 times 8 over 3 factorial. 10, then 9, 10 minus 1 is 9, then 8, 10 minus 2 is 8, over 3 factorial. 4 minus 1 factorial is 3 factorial, times a raised to 10 minus 4 plus 1, and that is equal to a raised to 7, times b raised to 4 minus 1, which is b raised to 3. 10 times 9 times 8 is 720. 3 factorial is 6. So 720 divided by 6 is 120. And copy the variables a raised to 7 and b raised to 3. And this is the fourth term of the binomial a plus b raised to 10. And that is all about the binomial theorem.